There are 28 students in 6A. Maybe I let them be A, B, C, D, something like that. And then until maybe Y, C, and then also alpha, beta, because there are 28 students. And then there are 4 spaces for us to choose. And beware that the first speaker and the second speaker are different. So that is very important thing. I reserve 4 spaces. For the first speaker, there are 28 choice. We have no limitation, so we just write down 28 choice here. And then for each person we chose in the first speaker, then we have 27 students left that we can choose. So this one time 27, the following less, and also the following. And we have to think whether we should divide the duplicate cases. For example, if we choose A, B, C, D, is that different from we choose A, B, D, C? This one is the third one, while this one is fourth one. Under this setting, we think that these two are different outcomes. So there is no duplicate cases. We don't need to divide by anything. So basically, this is part A answer. Or in textbook, usually we label this writing is among 28 P permutation 4. That means we have 4 spaces here, and then we have 28 choice from the beginning, and then it's decreased to 25 one by one. So that's why the answer is 28 times 27 times 26 times 25. It's 491400. So it's a huge number. At the same time, we are not asking for the probability, so we don't need to divide by the total, something like that. Now in part B, they say John and Sam already chosen. So maybe the 4 speakers are John and Sam, and then 2 more, maybe A, B, we don't really care about it. But anyway, we already choose 4 persons here as the speaker. And then we are going to find out the probability that John and Sam stay close to each other. There are many ways which makes sense to think about it. So one of the mainstream method is we consider J and S is a single block, and then other items is also a block. And then therefore we are going to consider within this block how many arrangements that we can have. It's quite obvious that only JS, John first, or Sam first. Only these 2 arrangements within this block. Afterward, we think about outside the blocks. We already secure that John and Sam stay together. But how many methods we can rearrange this 3 block? Maybe we put A first, and then B, and then JS. Or maybe we put A first, JS in the middle, and then B at behind. That means now in this case there are 3 spaces, 3 blocks only. And then the first space we have 3 choice. After we choose 1 block, then only 2 is left, and then only 1 is left. So this is 3 factorial. If we talk about 2 stages together, this one we give 2 factorial, and then this one we get 3 factorial. And the required probability generally is always the target outcomes number divided by the total possible number, total possibility number. So in this case, our target, we already counted, is 2 factorial times 3 factorial. And then what below total possibility is without any constraint. That means now I don't consider the block, but I just simply consider J, S, A, B, randomly rearrange it. Then we have 4 space, that means 4 times 3 times 2 times 1. So this is 4 factorial. Then we get 1 over 2. In other way to think about it, we may consider also J as A, B, 4 person chosen, and then under this situation, maybe we confirm A and B arrangement first. So the first stage, there are 2 factorial to rearrange them. Afterward, we are going to find out the space. So the second stage is talking about reserve the space to put JS. maybe we can put the whole block here, the whole block here, or the whole block here. So there are three choice here. Three. Or you may consider only one space we are going to choose, and then we have three choice. Now the last stage is talking about within the block. So the same as the first method is that JS or SJ. So there are 2 factorial to fulfill our requirement. Therefore, the probability is this time, this time, this, and then divided by without any limitation. 2 factorial times 3 times 2 factorial. Divide by 4 factorial. You still get the same answer, which is 1/2. It's because 3 and 2 factorial here is the same as 3 factorial.